Okay, so we move on to the second part of this derivation, which is in terms of delta. So now what usually happens is, sometimes in questions you will be given the value of n1 but you might not be given the value of n2. So in such cases, how do you calculate theta a or sin theta a? So for that, what we do is, we assume this quantity delta equals n1 minus n2 upon n1. You just assuming this n1 minus n2 upon n1 equal to theta. Now our goal is to derive an expression for the numerical aperture in terms of n1 and theta. So we'll start with the existing expression we have and we'll see if we can work out something in terms of theta. So you ignore theta for time being, let that just be there. You start with this n1 squared minus n2 squared, which is part of our original expression, the one we previously derived. So now this by mathematical identities can be broken down into n1 minus n2 times n1 plus n2, which can be approximated to n1 minus n2 times 2n1. Why is this? Because when you take n1 and n2, the difference between them is going to be of the order 0.01 or 0.05 something. The difference will only be in the second decimal point. It's not going to be a very substantial difference. So for example, if your core is 1.5, the cladding will be some 1.35, something like that. So you can assume that both of them are approximately equal. So n1 plus n2 is approximately equal to n1 plus n1, that is 2n1. So n1 squared minus n2 squared is split into this n1 minus n2 times n1 plus n2, which is approximated to be n1 minus n2 times 2n1. So what is our numerical aperture formula? Square root of n1 squared minus n2 squared, that is square root of n1 minus n2 times 2n1. How is that? We just derived it. So now just for the sake of simplification of calculation, we multiply and divide by n1. Then what do we get? n1 minus n2 to n1 squared divided by n1. And this quantity n1 minus n2 upon n1 is precisely what we assumed delta to be. So this on simplification becomes n1 times root of 2 delta. So why do we have this? Just because it is not always possible to precisely know the refractive index of your cladding. So in such cases, how do you determine the numerical aperture? You do not always need to know the value of n2. If you just have n1 and delta, that is more than sufficient. So a quick recap of what we did here. We assumed delta equals n1 minus n2 upon n1, and we started with the existing formula for numerical aperture and we wanted to derive something in terms of n1 and delta, meaning something which does not involve n2. So we split n1 square minus n2 squared as n1 minus n2 into n1 plus n2. We assumed this to be equal to 2n1. Then the expression for numerical aperture became this. We multiplied and divided by n1, we got this. On simplification, it became n1 times root of 2 delta.